Okay, in today's video, I'm going to go over how to draw ray diagrams for concave lenses and convex mirrors. This is the general diagram we're going to use. We need to know some of the important parts of this diagram. One of the important parts of this diagram is the principal axis. It runs right through the center of that lens in the horizontal direction, like the horizontal orientation. Then we have F, and we have 2F. F is a distance from the lens that is called the focal length. 2F is twice as far away, so we call it 2F. It's 2 focal lengths away from the lens. All right, now by the end of the video, we want to be able to, wherever we locate the object, that green arrow is the object, we want to be able to say where the image is going to be, regardless of where we put the object, whether we put it at F, inside, between, beyond 2F. For the image, we want to be able to say, first we want to be able to draw the ray diagrams, of course. And then for the image, and we want to be able to say what the location of the image would be, the size, the orientation, and the type. And really, before you even draw the ray diagrams for this type of lens and any other types of lenses or mirrors, you should really know what your answer is going to be so that you can draw them properly and just kind of know what's going on ahead of time. All right? So this is our first diagram. And you can see we have the concave lens and the object is between F and 2F. Now for all of these, both lenses and both mirrors, concave and convex, I told you that these are all drawn the same. Now they're not drawn exactly the same, but they're drawn basically the same. So for example, the first ray I like to draw is the ray that goes into the lens parallel. And then this is a concave lens, it's a diverging lens, so parallel rays are going to diverge. Okay, now the question is, how much is it going to diverge? How do we know how much to bend this angle when the light is refracted, when it passes through that lens? In the past, I've told you we draw this first ray so that it goes parallel in and comes out through F. Now, we're not going to bend it down this way through F. We're going to bend it up this way, and we bend it up that way so that it appears to come from F on the same side of the lens as the object. Okay, so just like we said before, this is called parallel. F, it's a diverging lens. It diverges so that it looks like the ray is coming from F on the same side as the object. Okay, so that's the first one, parallel F. Now the other one we said is F parallel. So we're going to draw this one as it enters the lens as if it was going to F on the other side, but when it comes out, it goes parallel. Okay, so that is the second ray, and your eye is on this side and it follows that ray backwards, and you trace it backwards carefully with your pencil and your ruler and a nice straight pencil, a nice sharp pencil, and it follows it back in that direction. Okay, so those are the first two rays we always drew. The first one being parallel F, F, parallel. Okay, this is for a diverging lens, obviously. Now the third one we can draw goes right through the center, and we drew the same thing for the convex lens. It goes right through the center. It doesn't refract. It doesn't bend. It goes right through the center like that. And you'll notice that your eye is over here. It sees those three light rays coming out of the lens as they're reflected off of the object. It follows this one back. It comes back through F. This one, it follows straight back, right? This one goes F parallel, your eye follows it straight back. Your eye follows this one straight back. Your eye follows this one straight back, and the image appears right there. That is our image. Okay? Now, you should remember that in the previous two videos, the one for the convex lens and the concave mirror, there were 5 different ray diagrams you needed to know how to draw. For the concave lens, okay, there's only one. It doesn't matter where the object is on this side of the lens. The image is always going to be between F and the lens, and I say behind the lens, on the same side of the object, you could always say, but I say behind the lens because here we are with our eye. We're looking, it's on behind the lens, on the same side of the lens as the object. It's always going to be between the lens and F. It's always going to be right side up. It doesn't matter where we put the object. It's always going to be right side up. It doesn't matter where we put the object. It's always going to be smaller. The image is always going to be smaller than the object. Of course, unless you bring the object right up to the lens that gets to be the same size. But for the most part, it's always going to be smaller, and it's always going to be a virtual image. This is an image that is created by diverging light rays. Okay, so once again, there's only one case. It doesn't matter where we put the object. The image is always going to be between f and the lens. It's always going to be right side up. It's always going to be smaller, and it's always going to be virtual. Okay, the image will never appear on this side, and it will never appear beyond f on this side. All right, let's go on and do the convex mirror. Okay, so once again, we have these important places we have to know about: principal axis, the center of curvature, and the focal point. And the focal point, this is the focal length, and the focal length is 1/2 the center of curvature. Now, this is a convex mirror. It's a diverging mirror. This side, the left side of the mirror, is the shiny side. Okay, so you'll notice the focal length, the focal point, and the center of curvature are on the other side, or as I like to say, behind the mirror. Okay, this is a mirror that's curved outwards. You're over here, the object is over here, the focal point and the center of curvature are on the back side of that mirror. Okay, just think of it, it's a spherical mirror, it's a big circle. C is the center, F is the focal point. It's halfway between the center, which this distance from the center of curvature to the mirror is the radius, and the focal point is halfway between the center of curvature and the mirror. Okay, so once again, regardless of where we put the object, the green arrow being the object, you need to be able to draw the ray diagrams to locate the image, and then you should be able to say where the image is going to be located, what size it's going to be, what its orientation is going to be, and what its type is going to be. All right, and really, once again, you should be able to say all of those things even before you draw the ray diagram. You should really know how this mirror works before, and that will help you to draw the ray diagram properly. Okay, so here is the diagram we're going to use. Here's your eye, here's the object, here's the mirror. Once again, the left-hand side, the side that's bending out, the convex side, is the shiny side, and we're going to draw these just like we've drawn all the others, parallel F, F parallel. So we draw the first one, the first ray goes into the mirror parallel, and then it is going to diverge, it's going to be reflected. Now, how do we know how big to make this angle, or how do we know how it's reflected? Well, it has to be reflected as if it was coming from F, and your eye is over here, it sees this light ray coming out of the mirror. It does not know that it was reflected right here, so it assumes it traveled in a straight line, so it assumes it came from F. So this light ray is bent, is reflected in such a way that it appears to come from F. Of course it does not, because this is a solid mirror and light can't travel through the mirror. So that's our first ray, just like we did in all the others, parallel F. So the next one, of course, is going to be F parallel. It's going to go into the mirror as if it was going towards F. But when it comes off of the mirror, it comes out parallel to the principal axis. Your eye sees that light ray coming out of the mirror. It assumes it traveled in a straight line. It doesn't know it was reflected off of that mirror, and therefore it goes back, and your eye follows that light ray back behind the mirror. Does it actually come from behind there? No, but your eye, your brain thinks that it does. And the next one, what we draw, the third one, is kind of just a check. It's going right towards C, so I draw it with my ruler and my nice sharp pencil right towards C. Of course, if it's going towards C, which is the center of curvature, it's already perpendicular to this mirror right here, so it's reflected straight back. And your eye sees that light ray reflected straight back, and it assumes it came in a straight line, and it assumes that that light ray came from the center of curvature. Okay? Now, once again, you'll notice that they all converge right here, and that is where the image appears. The image appears right there on the other side behind the mirror. Okay? Now, once again, just like we did in the previous for the concave lens, for the concave mirror, there's only one case we have to draw, really, because regardless of where we put the object, the image is always going to be between F and the mirror. You remember the previous one? It was between F and the lens. This is between F and the mirror, and it's behind the lens. Okay, it's behind, excuse me, this should actually say behind the mirror. It's going to be behind the mirror. This is behind the mirror. This is your eye. This is the other side. I call this behind. Okay, it's between F and the mirror, behind the mirror. It's always going to be right side up. It's always going to be smaller than the object, unless you bring the object right up to the mirror. And it's always going to be virtual. It is an image that is created by diverging light rays. Okay, so once again, I just want to point out there's only one case. You remember, for the convex lens and the concave mirror, there were 5 different cases you needed to know. But for the concave lens and the convex mirror, there's only one case, because regardless of where we put the object, the image will always be between F and the mirror. It'll always be erect, it'll always be smaller, and it will always be a virtual image. Okay, so thanks very much for watching. I hope that was helpful, and we will see you in the next video. Thank you very much.